This is part 2 of the series Calculus Prerequisites, and in this part we're going to begin by factoring by grouping. Now, as you remember with factoring by grouping, the object here is to come up with some information in at least two terms in the expression that's going to give you something similar again in both of those pieces. For example, let's take a look at the first problem here. In this problem, we need to break this thing apart into a set of terms that's going to have something in common. Now, sometimes it's a little hard, sometimes it's fairly easy. In this case, it's relatively easy because you can see in these two first terms, there's a common 3 inside here, and there's a common x in both of these. Actually, there's an x squared. And you can't be afraid to try something, and sometimes it leads you down a dark path, and you got to restart and see if you can do a different way. In this case, it looks like 3x squared is a common factor for both of these two terms. Let's see what that gets us. So we pull out a 3x squared, and if we take this term and divide it by 3x squared, we have 4x. And if we divide this thing by 3x squared, we have minus 3. And then we want to go ahead and rewrite everything else here. So that's plus 4x minus 3. Now you can see that we have a 4x minus 3 twice. Well, consider these as two separate terms. This term with the 4x minus 3 is being multiplied by 3x squared. This term of 4x minus 3 is being multiplied by 1. So if we pull out a 4x minus 3 here, here's one piece and another piece. We pull out a 4x minus 3, we have 4x minus 3. And then what's left is 3x squared plus 1. And that gives us these two terms factored. Now this is two squareds added, and that's not going to factor out, and this isn't going to factor out. So there's your final result. Now let's take a look at our second problem over here. Here we have the first two terms. Looks like we're going to group those together again. Notice that both of these terms have an x in them, and it appears that both of these have a 4 inside. So let's go ahead and pull out a 4x. And what's left, when we take this first term and divide it by 4x, we get 3y. Divide this by 4x, we get minus 7. Now let's take a look at these two terms. We clearly have a common 5 inside here. So what I'm going to do is I'm going to pull out a negative 5 because that negative sign is going to cause us problems. So I'm going to pull out a negative 5, and when we take negative 15y divided by negative 5, we get 3y. Take this one divided by negative 5, we get negative 7. Now again, you can see that we created two instances of 3y minus 7. So this expression and this expression both have a common 3y minus 7. So let's pull that out. 3y minus 7. And you realize when we're doing this that we're using the distributive property here. So 3y minus 7. When we take this expression and divide it by 3y minus 7, we have 4x left. We take this one and divide it by 3y minus 7, we have negative 5. And there's our two factors. All right, well that's a really brief overview of factoring by grouping. Now, the next thing we're going to be doing is other types of polynomials. And you're going to be getting involved with several higher order polynomials, quadratic polynomials, things of that nature. So that's what we're going to start doing next. But the first thing we're going to look at is how to break apart polynomials and we're going to take a look at polynomial long division. Now with polynomial long division, the idea is to break this polynomial apart into its constituent factors, and they're not always going to be even. This expression may not divide into this evenly, but even that is of value to us in calculus. First thing we're going to have to do, there are many different algorithms to do this. I'm just going to provide you mine. You can pick whatever one that you're comfortable with. The way I do it is I say, what do I have to multiply this term by to reproduce that first term? And so that value is x. X times x is x squared. So I put down an x here. Then I take this result and I multiply through all these terms. X times x is x squared. X times 1 is simply x. Now I change the signs of these two terms and add. Change the sign and add. Well, this goes to 0. 3x minus x is 2x. And then I just pull down my last term. Now we repeat. So what do I have to multiply x by to get 2x? Well, the answer to that is 2. So this is plus 2. And then we go and multiply these terms by that term. So this is 2x. And this is 2. Change the signs and add. So this is 0, and this gives us 3. Now we have this value. You can't multiply x by anything to get 3, so we're done. This is the quotient, this is the remainder, and so our result is x plus 2 plus, because it's a positive 3 over our divisor, x plus 1. Moving on to the next problem, we have x to the third minus 1 divided by x minus 1. You might recognize this as the difference of two cubes, but we're going to treat this just as a standard polynomial long division. Now, one of the key things in polynomial long division is your terms have to have an order of progression. We have to go linear, constant, we have to go cubed, to quadratic or squared, to linear, to constant. So we need to change this around a little bit. So we're going to have x minus 1 divided by x to the third plus 0x squared plus 0x minus 1. Because we need one of each inside here. From this point forward, the process is exactly the same as we did up here. What do I need to multiply this by to reproduce this term? Well, that's x squared. So that term is x squared. Multiply through x squared times x is x to the third. X squared times negative 1 is negative x squared. Now we change the signs and add. 0, and this is simply x squared. Now I bring down my other terms and start over again. What do I have to multiply this by to get x squared? Well, that's going to be x. And then multiply through. So we have x squared minus x. Again, change the signs and add. This is 0. This is x. Bring down my other term and continue again. We keep going until we can't go any further. Multiply this by this. Well, this is just a 1. So plus 1. Multiply through. We have x and minus 1. Change the signs and add 0 and 0. So we can clearly see here that our result is going to be x squared plus x plus 1. And if you remember our process that we did, we would say we take the cube root of the first term, which is x, the same sign, and the cube root of the second term, which is 1. Then to reproduce the second thing, we take this first term and square it. We use a different sign. We take the product of the two terms, x times 1 is x, and the second term squared, always positive because it's squared. And so we could have gotten it easier by just using our difference of two cubes, but this is a good example of what you have to do when you have to fill in missing terms. All right, let's do one more. And this is a little bit longer polynomial long division, but it's the same process. Here we have a quartic, a cubic, quadratic, linear, constant. Here we have the right order, so everything's good. Let's just continue. What do we have to multiply this term by to reproduce this term? That would be 2x squared. 2x squared. Multiply through. We have 2x to the fourth, 4x to the third, and minus 6x squared. Change the signs and add. This is 0. This is 0. Negative 5x squared plus 6x squared is x squared. Carry down our two terms. And start over again. What do we have to multiply this by to get this? Well, that's just 1. Multiply through. We have x squared plus 2x minus 3. Change the signs and add. And so we can't go any further because x squared doesn't go into x, so this is our remainder, x plus 1. And what we have is 2x squared plus 1 plus this set, x plus 1, over this expression. What we're saying here is that 2x to the fourth plus 4x to the third minus 5x squared plus 3x minus 2 divided by x squared plus 2x minus 3 is equal to this expression. Lest you doubt, just as an aside, I'm going to show you the work to multiply this through to change this complex fraction into the rational expression we just described. So here's the work. You can work through this at your leisure, but what I did was I just took this and multiplied this denominator by that term. So this reproduces this term. We just write this down. X squared times 1, 2x times 1, negative 3 times 1. We rewrote those, divided by that, and do the same thing with this term. That reproduces this, and simplifying this numerator gives us this, which is our dividend. So the rational expression is the dividend divided by the divisor. Dividend, divisor. So that's polynomial long division. Now in the next video, we're going to continue on with this idea, and we're going to look at an alternative to polynomial long division called synthetic division. I hope you remember that. Some of you may like it, some of you may not, but it's very nice when we have a divisor that's a linear binomial. So I will talk to you in the next video.